Good afternoon. Hello again. It's structural analysis made fun and easy. This is University of Bolton, Western International College, FCE. B.N. John, Civil Engineering, Semester 1 exam, 2016 to 17, Mathematics and Structural Analysis, module number CIE 4011. So this is question 2 of that paper. Simple pin jointed truss. Analysis, statical determinancy, equations of equilibrium of joints. This is part 3 of 4. Okay, please like the video and subscribe. Please donate to the channel if you can. So, okay, let's get back into it. So, oh yeah, here is the, this is the truss, and this is part 3. So in part 1 and 2, we got the support reactions, RA minus 40, RFH, RAH minus 40, RFH was 40, RF was 20, with a single point load at D of 20 downwards. So this is now part C, question, oh yeah, I just zoom in so you can see. Question 2, part C this is, and well, and advancing on to D. Using this method of using the method of resolution at joints, right? So that's also known as equilibrium of joints. Calculate the axial forces in the members of this truss and state whether each axial force is in tension or in compression. It should really say and state whether each axial force is tension or compression. It's not in compression. The member's in compression or in tension, but the force itself is either tension or compression. And part D, oh, that's 12 marks. So exam technique, 12 times 1.8 marks. That is, sorry about that. That is 12 plus 0.8 times 12. Is 96 divided by 10. So that's, so this one you got 21.6 mins. So oh yeah, so you got 21.6 minutes for this bit to find the to find in the do the equilibrium of joints and find the member forces. Just quickly say, so usually say vertical, what the axis and orientation is. Y usually drawn vertically, y-axis, up is positive, x is horizontal, left to right, positive, MZ, anti-clockwise, positive. Sorry, I can't draw it with a proper circle, it's a bit hard on Word, it's not that good. There's the truss that we've already been through. So AB was 40 in tension. BF was 28.8 something in compression, and EF was, I think it was 20. Oh, I can't remember exactly. No, sorry. Yeah, it was 40. EF was, I did it in the other video anyway, so it will be a bit later on in this video when we can put it exactly. And then part D is to finish off this diagram with all the forces drawn on. But this diagram is in progress, so I'll finish that in the last video. So this just shows you, well, let's just say for now, this diagram shows you that this AB is in tension, BF is in compression, EF is in compression. So now what we're going to do, we've done joint, we did joint A, we did joint F. So now we're moving on to joint B, because let's move on to joint B now, because we only have 2 unknowns at this point thanks to solving the member BF. So we're going to do equilibrium of joints at point B to find BC and BE. Let's move on to joint B now, because we only have 2 unknowns, and to this point, thanks to us solving the member BF. So here's the on the left hand side at the top, I've done the arrangement diagram plus with the force, the member forces direction. So member AB is going right to left. That's because it's tension. It's going away from the joint. Member BF equals 28.2845. If you want to know, if you don't know what I'm talking about, please go back to video number 2, because that shows you how I resolved, how I found these forces already. So we don't know what member BC is, and we don't know what member BE is. Just to recap as well, when you got a force, if it goes away from the joint, that's tension, and if it goes towards the joint, it's compression. So we got AB there. On the right hand side here, where I'm just circling it, but this is the free body diagram. So member AB. So the red arrow horizontal, right to left, tension, member AB. This then member BF was compression, 28.2845 kilonewtons. So BE is unknown and BC is unknown. So what I've done is, to start off with, I drew BC from left to right because I thought it's probably going to be from left to right because AB is from right to left. And also I've drawn BE downwards because BF, the vertical component of BF is going upwards, and we know that we need to balance the forces in the vertical direction. So that means that BE is it must be downwards, because if vertical component of BF is upwards, then BE must be downwards. So yeah, let's carry on that line of thinking. We do the vertical reactions first. So let's take summation of vertical reactions. Vertical component of BF plus member BE equals 0. Rearrange. Vertical component of BF equals minus B member BE equals minus 20. That means that it's downwards, i.e. tension, because it's going away from the joint. So we know that BE is minus 20 now. That's solved. So then we go back and let's do the second equation, equilibrium, horizontal. So the horizontal component of BF, that's going from left to right, minus member AB, which is right to left, plus member BC, let's say it's from left to right. So member BC minus, that means if we rearrange that equation, we get member BC equals member BC equals member AB minus horizontal component of BF equals 40 minus 20 equals 20 tension. So BC is drawing in the right direction, it's 20 tension. And BE is also in tension by 20. So there we have it, we've solved B. We've solved joint B, we know all the forces now. We know all the members that go into joint B. So, notes copied. Just to reiterate, a note about direction, tension or compression in this case, member BC is in tension, because the force is always away from the joint. If the force was towards the joint, then the member would be in compression. Remember this is very important. So BC is in tension and BE is in tension also. So now we've done that, okay, let's move on to joint C, support, because now we know that the BC force, there are only two member forces unknown, so therefore we can solve them. So just go, if you just to tell you what I'm talking about, so we're looking at joint C. Now we've solved joint B, now we're going to move one position, one bay to the right, going on to joint C. So this is the arrangement diagram for joint C. Member BC goes from right to left, that's tension. Member CE, we don't know. Member CD, we don't know. So on the right hand side here, we got the free body diagram. BC is from right to left. CE is coming in. Oh, let's say, again, we've got to make a guess. The horizontal component of CV must be opposite of BC for it to balance. And there's only one force of BC acting on the joint. Therefore, the horizontal component of CE was probably from left to right. No, it must be from right to left. From left to right, sorry. And that also means that if you're looking at vertical equilibrium as well, probable, if CE goes for CE is coming into the joint, then member CD must probably be going out of the joint. That one is actually, that could go either way, but we just started off because we know what BC is, and that's away from the joint. So CE, vertical, horizontal component of CEV into the joint. So have to start with vertical equilibrium. Oh yeah. Actually, sorry, that is wrong. We have to start with horizontal. We have to start with horizontal equilibrium, because we have to start with horizontal equilibrium as there is only one unknown horizontal force. Yeah, that's right. In this case, that of the horizontal component of member CE. Yeah, that's right. So we know what BC is, so we've got to find the horizontal component of CE. So minus member BC, because it goes from right to left, plus horizontal component of member, yeah, it should be, yeah, sorry, it's CE. CE, it should be CE, oh yeah. Horizontal, yeah, that's right. Horizontal component of member CE. So that's, if you look at that diagram at the top, so member BC right to left must equal to horizontal component of member CE. That means that if we draw out member CE with the vectors, so if it goes, horizontal component goes from left to right, that's probable that the vertical component goes upwards. Probable, yeah. Probable. It could be downwards, but I think I assumed that it was upwards. No, sorry, yeah, it has to be. Sorry, yeah, it has to be because of the geometry. This diagonal, so therefore the vertical component of member CE must be. It has to be upwards because member CE is pointing from left to right. And because we know that member CE is fixed on a 45-degree diagonal, then therefore the vertical component of member CE must be upwards. So now we can solve the rest of the joint. So the horizontal component member BF equals member BC equals 20 kilonewtons. I worked that out. I just done this in the last video as well, but tan alpha equals 4 meters divided by 4 meters equals 1 minus taken from the truss geometry. Oh yeah, sorry. Tan alpha equals 4 over 4 equals 1. That was taken from the truss geometry. So the alpha degrees equals arc tan 1 equals 45 degrees. So as horizontal member of CE equals 20, now find member CE force. So this is just a recap of trigonometry. So to find the angle alpha, that's the triangle. That's opposite adjacent hypotenuse, right angled triangle. So for member CE, cos alpha equals the horizontal component of CE divided by member force CE. Member force CE equals horizontal component of CE divided by sine alpha. Oops. That should be cos alpha. Sorry. Yep. Member force CE divided by horizontal component of CE equals cos alpha. Cos alpha equals 0.7071. Member force CE therefore equals 20 divided by 0.7071 equals 28.2845. That's to 4 decimal places. Oh yeah, and then we go on to the next bit. Sine alpha equals the vertical component of CE divided by member force CE. Member force times CE sine member force CE times sine alpha equals the vertical component of BF. Cos alpha equals 0.7071 equals sine alpha. That's the same, yeah. So the vertical component of CE equals 0.7071 times 28.2845 equals 20 kilonewtons. So the horizontal equilibrium is vertical component of member CE minus member CD equals 0. Here's the diagram for this one. So we're just finishing off member C, joint C. This is the this is like the free body diagram. So vertical, we're taking vertical equilibrium. Member CE, that's that one. Just highlight in blue. That's it. So member CE, member CD downwards. That means the vertical component of C CE must be upwards. Oh yeah, member CE. So this is from left to right. Horizontal component, member CE, vertical component, member CE, member CE. V component of member CE equals member CD. Member CD equals 20, so that's okay. Check tan alpha equals 1. 1 equals vertical component of CE divided by the horizontal component of CE. Therefore, horizontal component of CE equals vertical component of CE equals 20. So that's it. So this joint C is totally solved. That's easy. Very easy. Let's move on to joint D. Oh yeah. That's the only thing that's unknown now is joint D. Oh sorry, no, B. Yeah, we haven't solved. I think. But what we have, we've found B, E, and C, E. So when we go back to joint B now, the only thing we don't know is member ED. Oh yeah. So due to technical issues, oh yeah, I've got to keep the videos under 20 minutes because I had problems with the file sizes. So sorry, I can't do this video. It's not. I'm not trying to trick people into watching more videos. It's just that videos got to be less than 20 minutes. Otherwise, the file sizes are too massive. So hopefully see you in the final part of this series for the rest of the solution, and then I can finish that diagram. In the next video, I'll finish off the diagram because that's part D of the question. Part D of the question is summarize your answer on a diagram of the truss layout at 3 marks. So that's like all we don't know now is remember ED or DE, whichever. We know BC, we got BE, we got CE, we got even CD. That's 20. That was 20, wasn't it? CE is 28 again. BC was, I think it was 20. But I'll finish it properly in the member BE. Member BE is member BE is minus 20, yeah, 20. So just to see you in the final part of the video. Then this series will be completed in the next video. This is just under 20 minutes, so that's perfect. Please like the video, please subscribe to the channel, please donate and support the channel if you can. Please leave a good comment, all helps. Thanks for watching.